the presentation on is titled The Soundscape Patterns of Urban Space with varying, varying degrees of connectivity metropolitan soul. Excuse me. Well, it's your time.
Yes. So now I'm start. So hello.
It's fine.
My name is Soyeon Che, and PhD degree student in Ewha Women's University. So today my topic presentation is the sounds acoustic index pattern of urban green space with varying degrees of size and connectivity in metropolitan Seoul. So today's presentation is what I hope to become a part of my thesis for graduating in the future. So it is not complete yet, but if you have any advice or question, is anytime tell me. So recently, urbanization has become more serious around the world. As it becomes more serious, represent an extreme form of environmental change and is a major driver of biodiversity loss and habitat fragmentation in the different phases may have several effects on distribution and movement of species. As fragmentation continues due to urban development, species become smaller in population. When it becomes small groups, signal variation in small population. For example, in the field, cricket inbreeding depression can directly affect sound production and the acoustic property of signal. And other example, other species, it is social selection that mediates the population size acoustic behavioral relationship. Noise is also a problem in the urban. Anthropogenic noise is the impact that most directly disrupt and affect the acoustic modality of communication. A number of bird species have shifted some frequency, duration, amplitude, and timing of singing to avoid masking trapping noise. And other examples in the few amphibians have been found to adjust their temporal or frequency curve structure to increase the efficiency information transfer in noisy habitat. So trapping noise can mask rustling sounds made by moving arthropod, eventually reducing the foraging efficiency of bat, which depends on echolation for feeding. In this problem, animals are undergoing various changes. Among them, there is an issue related to habitat. Therefore, urban green space is very important thing. So urban green space is the nature and semi-nature picture in urban. For urban animal, green space will therefore be an important factor in habitat. It is distribution and migration. And then this space provides opportunity for biodiversity ecosystem. Therefore, crucial to understand how biodiversity responds to different types of urban green space. So why understand the urban soundscape? The urban soundscape can have consequences on the well-being and quality of life for humans. In recently modified environment, such partitioning is less evident. and the occurrence of frequency and time overlap between species can reduce the efficiency of intra and interspecific communication. So, Soundscape can find several environmental application assessments of the environmental quality of park and protected area. Second, make urban planning and design. Third, understand ecology and anthropology. Finally, do the long-term monitoring of the effects of climatic change in geophysical and biological contexts. So why I'm focusing this size and connectivity? As habitat is lost, landscape become more fragmented and less connected, usually with negative effects on biodiversity. And acoustic diversity became an index of estimation of the complexity that we can expect in a specific site or habitat. So the soundscape ecology coupled to bioacoustic approach can explain the effect of some landscape patterns such as edge and size and shape of patchy on vocalizing animals. So general question, how does the acoustic index pattern appear differently depending on the size and connectivity? So I explain my measure and method. I recorded from May. I using the Audimus sampling rate 44,010 Hertz, and I recorded from May 2019 to April 2020, twice a month. And total recording file is 34,516 in each site. And site selection is these 3 sites in each grade according size, and measure the connectivity grade 1 to 5 each site using GraphPad. So this picture is my sampling site. So this red here is urban site. So I using only this green patchy because that part is connect the other natural preserved park. So I focusing this more smaller and fragmentation patchy. So I measure the size and connectivity. I downloaded about the land cover use tests from public open access. For example, this green space is grassland and forests, and this pink is commercial area, and this red one is transport area. So I extract only green space here and select the random select the red spot. And then measure the connectivity. I give this score to length time. For example, good score was given to organism to use, transportation or commercial area where it is difficult for organism to move will receive the lowest score, and the connectivity between each patchy was measured. So this patchy and this patchy have each node, and then I connect the each patchy, and that patchy and that patchy in here, this white make a score and then divide into 5 grades in according the connectivity. So this 12 sites is my sampling site. So A is over the 1 million, and that site's connectivity is 351. So 5 is highest connectivity and 1 is lowest connectivity. And B is around the 100,000, and C is around the 10,000, and D is 1,000 size. And then recording pile analysis acoustic index. This I used this 10 index. And then I use the cross-call test because can conclude that there are significant difference between the group size, patchy size, and connectivity. So all test is p-value is significant, and then I did the analysis post-hoc from Ferroni because to calculate pairwise comparison between patchy size and connectivity level with correction for multiple testing. The results showed that most of the index were significantly different depending on the size and degree of connectivity, except AR and ACI. So you can see here more. See here, these 4 indices show significantly differences according to size and level of connectivity. For example, size scale is small, AEI index is increased, and connectivity is increased, and AEI index is the lowest. So this AEI and ADI and DSI BI is show the strong tendency. And acoustic entropy index in amplitude index is also show the significant differences according to size and connectivity. Also show the tendency following the grades. But some acoustic index show the faint tendency. So temporal entropy index is except 2-3 parts is not significantly different. And then spectral entropy index is size grade is not significantly different. And not all indices differ significantly by the size and connectivity. Look, AR and ACI is not different in size grade and connectivity grade. These two, so I want to look at these 2 index more precisely. These 2 index need to, so this AR is really similar, this all sites, but ACI is little bit different at each site. So AR and ACI need to combine analysis for size and connectivity, and I need the elaborate analysis. So summary and discussion. So first, the pattern of the acoustic index appears differently depending on the size and connectivity. Afterward, I need to identify which indexes are good for distinguishing the acoustic diversity in urban ecosystem. And actually, in some cases, the results were different from I was expected because these sites are that many people are pass and transport amount is high. There are many problems in dividing and calculating biophony in urban ecosystem. And some case, urban ecosystem construction often occurs. Therefore, the effects of these events on acoustic diversity should be identified. Afterwards, I will this research did do. Current research size and connectivity are grouped separately to see the difference in acoustic index. But it is necessary to analyze the difference in acoustic index using the novel ecological index, combine the size and connectivity, or I make the new ecological indicator. And there are limitations due to acoustic index analysis focusing only on urban ecosystem. For more accurate results of urban ecosystem, comparison with natural sound ecosystem is necessary. Because of this, we establish a better acoustic evaluation index and criteria for urban ecosystem through comparative analysis of acoustic index of nearby preserved natural park or ecosystem. So thank you very much hearing my presentation and take time of your schedule.
Okay. Thank you. Can you stop your sharing video, please?
Okay.
Thank you. Thank you. So we open for discussion. There are questions. Okay. I think that you are focusing on a very important topic, especially because the environment, the urban environment is spreading everywhere, and so we have a lot of problematics to face with such a system. Can you explain more your vision about the development of such an urban system in your area, for instance, if it's will increase, what are the possibility to discourage to the fragmentation or to encourage the plantation and so on. Some idea about such an important environment that is a new environment, is a hybrid environment, and that was a lot of changes in terms of monitoring and in order also to find a solution to maintain or to enrich the biodiversity. Yes, please.
So I did the analysis. I think that connectivity is very important for that. So today research, I only measure some patches connectivity, but I think that I need to other patches measuring the connectivity, and then different grade is how they show how these patches showing the vegetation and biodiversity, and I connect this ecological indicator I need. Yes, I think that connection area make needs.
So I think that the connectivity is a process really important for allowing anyone to move from one area to another. Of course. So it's a central topic in this type of environment. Yes.